All right, example 4. Identify the intervals or intervals on which the function y equals x squared minus 2x minus 3 is positive. Identify the intervals on which the function is negative. Now, with a parabolic function, a quadratic function, there's a simple way to find this, but I want to go through the little bit more complicated way because I want you to be able to do it with all functions instead of just quadratic functions. And with that in mind, this is the thought. Okay, so imagine we have an xy graph. Just a normal xy system like this. And we have a graph that looks like just whatever it looks like. So let's just say it's going to look like this right here. Okay. What I need you guys to understand is when the graph is positive, when the graph is negative, they're talking about the height of the graph. X equals 0 is neutral. Everything above the x-axis represents a positive graph value. Everything below represents a negative graph value. So when they say, when is the function positive, they're asking when is the graph of the function above the x-axis. When they're stating the question, identify intervals on which the function is negative, they're asking when does the graph live below the x-axis. All right? And what they want to know is what the x value is where that happens. So if I'm going from negative infinity to positive infinity on the x-axis, that's where x lives. You can see that the switch from positive to negative occurs right here when the graph equals 0, and right here when the graph equals 0. At a height of 0, the graph can change value from positive to negative or vice versa. Okay? Our task is to identify the intervals where that happens. So I need to find out what these two numbers are here. And then establish some intervals and then to test those intervals. That's how I'm going to do it. And again, for a quadratic function, I know if x squared is positive, it turns upward, right? So if I get my zeros, it'll be positive here, negative there, positive there. If it was negative x squared minus whatever, it would look like this. And now it'd be negative here and positive there and negative there. So again, with a parabola, it's easy enough just to look at what the graph should look like and get an idea of what it should be. But again, I want you to be able to do all functions, not just quadratic functions. So when we visit this topic again with more complicated functions, we'll have a technique that works all the time. So the method that we're going to use here involves first off finding out exactly where the graph hits the x-axis. So I want to know when does y equal 0. So I take my equation that they gave me that involves x and y and I change y into the number 0. So if I take this equation up here and change y to 0, I'm going to get 0 equals x squared minus 2x minus 3. My task then to solve this quadratic equation is to factor using whatever technique of factoring is necessary for it. This having a 1x squared tells me I just need the two numbers that multiply and add, right? And very similar to the last problem, right? It's going to be x minus 3 times x plus 1. We'd agree that that's the factored form that makes this quadratic structure. Negative 3 times 1 makes negative 3. Negative 3 plus 1 makes negative 2. Then applying the zero product property again, I know that either x minus 3 equals 0 because that's factor 1, or x plus 1 equals 0 because that's factor 2. In both cases we have a variable in those, so we have an answer that we can get. I'm going to subtract or change the minus 3 into plus 3. So then the x equals positive 3. Chop the 1, move it over, becomes x equals negative 1. So that's task 1. Find out when the graph is going to touch the x-axis. When can the graph switch from positive to negative and vice versa? All right. Once we find those two numbers, that's applying what we already know how to do. Now this is new stuff. We want to create intervals. All right. So what I've got going on here, this is negative 1, this is 3, right? That's where we're hitting. So basically I got negative 1, 0, and 3, 0, 2 points on my parabola. And again, this one turns upward, so it looks like this, right? So this interval here is from negative infinity to negative 1. This interval here is from negative 1 to 3. And this interval here is from 3 to infinity. The intervals are all about x. We've already established y is going to be either positive or negative. We're concerned about what x's make that happen. So once you find your zeros, start at negative infinity, go to the first one, the smallest one, then go there to the next biggest one, and once you hit the biggest one, go from there to infinity. So I've only got 2 zeros in this case, so negative infinity to the smallest -1, -1 to the biggest 3, the biggest to infinity, and the end. So you make 3 intervals when you get 2 zeros. All right, so now we have to pick 3 test values for x. Here's the rules for picking a test value. You've played this game before. Pick a number between 1 and 10, right?
11.
That's not a good guess. 7 works, all right. But instead of pick a number between 1 and 10, we're going to pick a number between negative infinity and -1. Larson, pick a number between negative infinity and -1.
-1,000.
Negative 1,000.
-6,400,000.
I would have gone with -2, but negative 1,000 will work. It doesn't matter what number you pick. Any number that fits in the range will be fine. Jerica, pick a number between -1 and 3.
1.
Perfect. 1. Between -1 and 3. Dominic, pick a number between 3 and infinity.
5.
5. Perfect. All right. There's no wrong answer as long as those numbers live within. If I said Dominic picked a number between 3 and infinity, he said -7, that's the wrong one, right? But as long as he's in, if he said 5, 24, 4, 17,947, whatever, as long as it's in that neighborhood, you're fine. The one's between there, and Larson, of course, picked -1,000, that's perfectly fine. Good job, Larson. So you answer questions, you just say smart things, that's awesome. All right, so, now, what I'm doing with these test values is this is what x equals. X equals -1,000, x equals 1, x equals 5. Now the nice thing is it doesn't matter what the number answer is, what matters is the sign answer. You only care about the sign, positive or negative. And what we're evaluating exactly is this product here. X minus 3 times x plus 1. That's what is the same as x squared minus 2x minus 3, but that's in its simpler form, it's in the factored form. So, I'm going to test -1,000 by replacing x right here and right here with -1,000. And again, I don't care what the number answer is, I just care about the sign. If I do -1,000 minus 3, what kind of answer do I get? -1,000 minus 3. Negative. If I do -1,000 plus 1, what kind of answer do I get? Negative. If I multiply 2 negatives, what kind of answer do I get? Positive. Which justifies what we see here, right? From negative infinity to -1, the graph's above positive, right? If I'm testing x equals 1, again, replacing x equals 1, and these two things here, here's my parentheses for the first and second. 1 minus 3 is -2. 1 plus 1 is +2. Negative times positive makes a negative. Then I'm testing x equals +5, replacing both x's with the number 5. 5 minus 3 is +2. 5 plus 1 is +6. Positive times positive makes a positive. Again, don't worry about the numbers, just worry about the signs. We're multiplying, so the multiplication rules are in effect. Same sign positive, different signs negative, same sign positive. So I can see that the graph is positive from negative infinity to -1 and from 3 to infinity. I can see the graph is negative from -1 to 3. Now, the book, when they asked these questions, they asked either one or the other, not both. I did them both just so you can see how to do both. All right? But usually in the book, they'll say, when's it positive? And you just write the positive ones. Or when's it negative? Just write the negative ones. All right? But that's how you do it. That works on any type of function you ever see. You simply get the function in a factored structure, find the zeros where the signs can change, and then just test the intervals and figure out it's positive there, so it's positive everywhere. It's negative there, so it's negative everywhere. It's positive there, so it's positive everywhere. Again, the sign can't change until you get to -1. So if it's positive there, it stays positive until it hits 0, then it jumps down to negative until it hits 0 again, then it jumps up to positive. So that's all this is. Identify the intervals as the x-axis intervals.
Simple.
All right?
Fast.
Now, real quick, let me stop the video.